All right, now the last section of our root simplification in 6.3 involves roots that have a little bit more going on. And these ones, again, we can combine with addition and subtraction too, beyond just simplification. So for number 19, when we are taking a square root, first you want to look at the constant. 9 happens to be a perfect square, so I'm going to be able to bring a 3 directly out from the root. Now there's really a 2 when you're doing a square root operation, which is important when we start to consider the exponents. So on the x, this number, when I divide it by 2, is going to become a 5. For my y's, when I divide 6 by 2, I'll get a 3. And then for my z, when I divide 2 by 2, I'll just get a 1. So it'll be a z by itself. So that one works out perfectly. There's nothing left inside of the root that I have to worry about simplifying. We've been able to remove everything entirely from the root. Then for number 20, this one, what I need to do is figure out what cubic roots can divide into 81, because 81 is not a perfect cube itself. So the number that's going to work is 27. So we'll have 27 times 3 times 8 to the 9th. 9 is great because 9 is divisible by 3. And then with the 8, this is a little bit of an issue because 8 is not divisible by 3. So the closest number that will be divisible is going to be b to the 6, because 6 will divide by 3, and I'll have 2 left over. So then I can start to remove things from the roots. The cubic root of 27 is going to be 3, so I can take that out, but then this 3 will be left inside, so I can kind of start my cubic root for what's left over here. So I'm going to have a 3 inside. Then a to the 9th is going to work. It's going to become a cubed. B to the 6th is going to work. It's going to become b squared. And then the b squared, can't do anything with that, so that will be left inside of the root operation here. Last one that we have is some quartic roots. And this quartic root I want to split up into 16 times 5, because that's going to be the quartic root that divides into 80. And then I'll have an a cubed and a b to the 16th. So the cubic value is going to have to stay inside. There's nothing about 3 that is divisible by 4, and it's smaller than 4, so I'm not going to have a number before it that is going to divide out. So when I start to simplify, 16, when I take its 4th root, will become a 2. And then in the quartic root, I'll be left with a 5. The a cubed has to remain there. The b to the 16th is going to become a b to the 4th out in front. And that's my simplified answer. So again, I want to be able to do these when the roots are by themselves. Also, I need to be able to do these kinds of operations the same way we did 18. So I want to be able to recognize that after I've simplified something, I would be able to add or subtract in combination as long as the terms that are inside of the root match and they're the same index root. Otherwise, the process is the same. So there could be one like that as well. There's one like that in our in-class review and some of your homeworks. Now, number 22 is where we get into function operations and function composition. So first, this asks us to identify the domain and range of the functions. We focus specifically just on domain, so we can go ahead and just identify the domain. For both of these, our domain is going to go from negative infinity to positive infinity, or we can say all real numbers. And we'll focus more on the range again when we come back to our graphs on Thursday. Now, the reason why they're all real numbers is that there aren't any restrictions on what we can plug into either a polynomial or a cubic root. What we really want to watch out for as far as where there will be restrictions is our even valued roots. So for example, if you have something like x to the 1/2, you can't plug negative numbers in here as far as getting real valued numbers out. So this domain would go from 0 to infinity, or we'd say x is bigger than 0, greater than or equal to 0. So negative infinity to infinity will work for these. Oops, I just switched my document somehow. Then we can see what else we can do with these operations. So first step in part B, we are multiplying. So f of x times g of x just means I'm going to copy down my f of x, which is x cubed plus 1. And I'm going to multiply it by my g of x, which is 4x to the 1/3. So when I multiply x cubed by 4x to the 1/3, those both have x's in them, and so I need to add those exponents. So I'm going to be adding a 1/3 and a 3. So this 3 needs to become 9 over 3, so that way I can add. So I'll end up with 4x to the 10/3. And then the 4x to the 1/3 also has to get multiplied by 1. So this will be my final answer there for the multiplication. Then I have g of x times g of x. So that just means I'm going to have 4x to the 1/3 times 4x to the 1/3. So I'm going to multiply the 4 and the 4 to get 16. And then I'm going to add the 1/3 to end up with 2/3. Then I have f of 2 plus g of 1. So f of 2 just means I'm going to plug a 2 in where I see an x. So I'm going to get a 2 cubed plus 1. And then for g of 1, I'm just going to plug a 1 in where I see an x. So then let's simplify this. 2 cubed is going to be 8, plus 1 will be 9. And then with this operation, I have 1 to the 1/3, which is just going to end up giving me 1 as well. So I'll have 1 times 4, which will give me 4. So 9 plus 4, my final answer here is going to be 13. Now I have f of g of x. So this is my function composition work. With this kind of operation, I would recommend first rewriting this as f of whatever the expression for g of x is. So f of 4x to the 1/3, which then tells me where I see an x in this operation, I'm going to fully substitute in a 4x to the 1/3. So that's going to become 4x to the 1/3 cubed plus 1. And so here this 3 needs to go to the 4, so I'm going to have 4 cubed times x. I'll have 3 times 1/3, which will just become x to the first power, plus 1. And I'm going to go ahead and simplify that. 4 cubed will give me 64, so I'll have 64x plus 1. So that's my function composition piece. And then it asks me to find f of g of 8 for part f. So I have two ways I can go about doing this. I just found f of g of x, so I can just plug 8 into the operation we found up above. So I can call that 64 times 8 plus 1. So I'm going to have a little bit of multiplication going on there. So this will end up giving me 512 plus 1, or 513. So that's one way you can do that operation, is if you've already found the function composition, just evaluate it at the point that's provided. The other way we could have gone about doing it was first finding g of 8. So if you did g of 8, you would end up with 4 times 8 to the 1/3. And 1/3 are, as fractional exponents, are the same thing as a cubic root. So this is 4 times the cubic root of 8, which is 4 times 2, which is 8. And then I would take that number and plug it into the f function. So I'd have f of 8, and it's just a coincidence that that matches up to the original number here. And I'd have 8 cubed plus 1. And if you take 8 cubed and add 1, you'll get to 513. So you can either do it as two separate function plugins at a specific number, or once you've found the function composition, just plug it in. Either way is going to work. So that's true for g of f of 0 as well. So with this one, let's do the numerical one first, and then we can just prove that the function composition gives you the same answer too. So this first says find f of 0. So if I find f of 0, I'll have 0 cubed plus 1, which is 1. And then I'll take g of 1, which is going to be 4 times 1 to the 1/3, which is just going to be 4 times 1, or 4. So that's the numerical way. If I did it the function composition way, I could find g of f of x, which means I would find g of x cubed plus 1. And g of x cubed plus 1 would be the same thing as saying 4 times x cubed plus 1 raised to the 1/3 power. So if I wanted to plug 0 into this operation, I'd end up with 4 times 0 plus 1 to the 1/3, which is going to give me 4 times 1 to the 1/3, which is going to give me 4, just like we found doing it the other way. So either approach is fine when you're working with numerical operations. So that's it for this study guide. Continue to review your in-class notes, your associated homeworks, the in-class review from Friday, and then these problems. If you're looking for any additional practice problems, you can certainly find corresponding ones to these sections, or ask me for suggestions about them from your textbook. Otherwise, our quiz will be in class tomorrow, and then we'll also start with a video of section 6.4 tomorrow too, so we can continue on with our pacing. Thank you guys.